Laws of logarithms. There's 3 laws. That's all we have, 3. They're pretty easy to remember. It's kind of like a puzzle. Okay, so pay attention and you will be a pro at laws of logarithms. Okay, the first law is this. It is the multiplication, and I'm gonna try using color on you here. Multiplication, I'm just gonna abbreviate, okay, that's what the word is, slash addition. Okay, multiplication slash addition. So we're going to use multiplication and we're going to use addition. Now, in my little brain, those two signs look kind of similar, right? That's how I remember. They look alike, sort of, kind of. Alright, so this is the deal on law 1. Log base b of m times n, that's my multiplication portion, right, equals log base b of m plus log base b of n. So it gets split. Now, you can go back and forth. You might start here. I want to break it apart. They might start you here, and you want to put it back together, right? So this is an expansion, and this is one that's expressed as a single logarithm. Single logarithm and expansion. Multiplication, addition, they go together. The signs kind of look alike. Law 1. Here's an example for you. Log base 2 of 6 really is log base 2 of 2 times 3. Oops, I've got my base. That's base 2. Sorry, squeeze that guy in. Which equals log base 2 of 2 plus log base 2 of 3. Okay, so there's an example for you, and I'm going to show you a little bit more about these in just a few minutes. But I took this one, I said 6 is 2 times 3, I said 2 times 3, and then I split it up. Okay, that's law 1. Law 2 is the division, subtraction, division slash subtraction. I'm just using different colors so you can tell the difference here. Now, in my brain, also, these two signs look alike to me because they both have a minus sign in them. See it? There's a minus sign in the division sign and then a minus sign there. Just the way I remember it. I know they don't really look alike. Kind of. Okay, and this is the deal on that. Log base b of m over n equals log base b of m minus log base b of n. So I go from division, see the minus sign? Division to subtraction, and I am expanding it. So I go from a single logarithm to an expansion. Okay, those are the two main laws of the two big laws. Let me give you an example of this one if I can think of something here. How about this? Log base 3 of 7/3. How about that? Let me think if that's logical here. Equals log base 3 of 7 minus log base 3 of 3. Okay, so something like that is what it would look like. So if you have division, you go into subtraction. Now they might want you to go this way, and they might want you to go back that way. Okay, and they'll ask you for what they want. The last law, law 3, is one that's used together with 1 and 2. So this one isn't used separately, it's always used together. And this one is the exponential. What's the exponent one? Okay, it's the exponent one, and what it says is this, is log base b of m to the k, so now it has an exponent, right, equals k, oh, we get to move it, log base bm. Okay, so we're moving it. That's what that one is. So for example, log base, let me see what I have, log base 6 of m squared, right, equals 2, gotta move it, log base 6 m. Okay, so there's a little example for you. Alright, so those are my 3 laws of logarithms. Okay, so multiplication, addition go together, right? If I'm multiplying, then I can split it up. And they're not going to show you what multiplies out. You're going to figure that out. Okay, I figured it out. There you go. Division goes into subtraction, and when you have an exponent, it gets to jump right here in the front. If you're expanding, if you're putting it back together, then it goes back up here as its exponent. Alright, now let's look at an example. These are usually used together. I'm going to switch pages on you because I'm going to run out of room. And I will show you what I mean. Alright. Okay, so laws of logarithms continues. Alright, here's an example for you. These are really easy if once you play with them. Okay, there's going to be an aha moment when you get it. But you got to play with them and gotta just play with it and then look at the answer and see if you got it right. And if not, then fix it up and try again, and pretty soon you'll be a pro. Alright, so let's say I have this log base 10 of a squared square root b. Okay, so what do I do with this? Well, the first thing I'm going to have to do is I kind of have a radical in there, so I'm going to change it to an exponent. Okay, so I'm going to have log base 10 a squared b to the, what do you think? I have the square root of b, so it would be b to the, it's b to the first, what's in that v is a 2, so to the 1/2. Now I'm going to split it, so I would have log base 10, and this is multiplication, these are being multiplied, and I know that what goes together with multiplication is addition, so I have log base 10 a squared plus log base 10 b to the 1/2. The last thing I'm going to do is law 3, and I'm going to pop this exponent down in front. So I have 2 log base 10a plus 1/2 log base 10b. And I'm done. that's all I need to do. So let's give us a couple of little 1, 2, 3s here. So the first thing is everything needs to be expressed in exponential form. Okay, not just what's inside here. Okay, so if you have a radical, so let's say this, if you have a radical express as an exponent, how about that? Okay, if you have a radical expressed as an exponent, that was the first thing I did. Second thing I did, I decided if I had addition or subtraction, right? Which one am I expanding to? Okay, well, it was, so you need to know, which one of these is it? Here, let me do this. Is it multiplication? Uh-oh, dropped my pen. Addition? Is it that one? So I'm just asking myself some questions, and I have 15 pins in my hand and they're falling everywhere, and I can't pick them up. Or is it division slash subtraction? Yeah, what I got? I don't know. Which one is it? What do you think? Looking at this one, what do you think? Well, what I had was multiplication, addition, right? Because these are being multiplied together, so I know that I went to addition. Multiplication to addition. Okay? So it was this one. And then I guess my third thing was, because then I used that, my third thing was I'm just going to say this, use law 3. Okay? So there's some steps as I pulled it apart. Let's try that again. Ready? Try it again here. Log base 10 of a to the 5th over the square root of b cubed. Okay, step 1, if you have a radical expressed as an exponent, I have a radical. Oh, I need to express it as an exponent. B to the 3 halves, right? Now I need to decide, is it multiplication, addition, or division, subtraction? Ah, division, subtraction. Look, there's the sign there. I have log base 10, a to the 5th, minus log base 10, b to the 3 halves. The last thing I'm going to do is use law 3. Okay, law 3 is that exponent law where that exponent's going to pop in front. So I have 5 log base 10a minus 3 halves log base 10b, and I'm done. What do you think? Not so bad, right? Okay, now this one they're asking you to expand. So this example is expanding, and I'm gonna write that right up here. But sometimes they ask you to express as a single logarithm. Okay, so if they ask me to express as a single logarithm, all I'm going to do is I'm going to take these and I'm going to go backward. Okay, so now I'm going this way. Let's see if we can fit that on this paper here. So, so here's an example of express as a single logarithm. Okay, so express as a single logarithm, that means I'm going to go this way. So if you want me to expand it, I'm going to go this way. If you want me to express as a single one, I'm going to go that way. So let me show you what I mean. Alright, so I have 3 log base 2m minus log base, you know what, that's not, it should be a 6 and not a 2, sorry. That's a 6. Log base 6n all over 2. Okay, and that's a 6. That's a really ugly blob of a 6 because I messed up. All right, so now this one's already taken apart, right? This one looks like the answer on these. Well, I want to take this one and I want to put it back up as one logarithm. So I'm going to go this way. So use law 3. Okay. Well, that means this 3 needs to pop back up here by this m. So I have log base 6 m cubed minus this 2 under here. This, it really looks like this, and I'm just going to write it out for you. Log base 6n. Really, you have a 1/2. Okay, so that 1/2 then is going to pop up on that n. So I have log base 6n cubed minus log base 6n to the 1/2. Okay, now is it multiplication, addition, or division, subtraction? Well, this is definitely subtraction, so I know that I'm going to go into division. So what I'm going to have is log base 6 m cubed all over n to the 1/2. Okay, well, we said something about, you can see I'm almost off of the paper here. I'm going to just scoot this up a little for you. There we go, that should work. We said something about radicals here. If you have a radical expressed as an exponent, well, guess what? If you have an exponent that's a fraction, you need to express as a radical. So what I would end up with here is log base 6 m cubed all over the square root of n. And that would be my answer. Just try to make sure it got it all in here. Yep. Okay? Are you with me? Are you with me? Are you with me? Okay. How about this one? 4 log base 10 p minus 2 log base 10 of q. All right. Use law 3. I'm going to use law 3. I should have done an addition one. Can I change it to addition? Would you have any problem with that? I'm going to change to addition. Oop, I changed it. Okay. New problem. I did subtraction there. Hey, I wanted to do something with addition. So here we go. I changed it to addition. Okay. You don't get to do that. I only get to do that. Okay. Use law 3. So log base 10 p to the 4th. That 4 pops up here. Plus log base 10 q squared. Pops up here. It's addition, so I'm going to go to multiplication. So I'd have log base 10 p to the 4th q squared. If you have a radical expressed as an exponent, or if you have an exponent that's fractional, right, expressed as a radical. But I don't. I have a 4 and a 2. So I'm good. That's it. I'm done there. Okay? So that's me using a few of my laws, or all my laws actually. I've used all my laws, show you how they work, gave you some steps, and let's move on. We don't have a whole lot more. This one's pretty quick. Okay, I'm going to change my paper. Let me just make sure I'm where I need to be here. Okay, so this is the laws of logarithms. Continued. I end up with a lot of pages. Okay, now this part is going to be your confusing part, and don't worry, you know, we're going to work on this in class, so don't worry too much. Here's some instruction. Given that log base 2 of 3 equals 1.585, because they do equal a number, right? I should show you that on the calculator. And okay, this one particular piece cut out on my video. So given that log base 2 of 3 equals 1.585 and log base 2 of 5 equals 2.322, find the following. Log base 2 of 81. Okay, so this is what cut out on my video here. Alright, well the deal is with these that log base 2 of 3 equals 1.585, so it actually equals a number. And log base 2 of 5 equals 2.322. It actually equals a number. So I'm going to express log base 2 of 81 as some combination of log base 2 of 3 and log base 2 of 5, or not a combination, just log base 2 of 3 is kind of what I'm thinking here. So what I would have is, instead of log base 2 of 81, I would go log, sorry, not writing very good, pen is dying on me. I would go log base 2 of 3 to the 4th. So log base 2 of 3 to the 4th, I would use my law 3 and I would pop that 4 right in front of log base 2. So what I would end up with is 4. I don't know why my pen is deciding to die on me now. 4 log base 2 of 3. Well, log base 2 of 3 equals 1.585. So I'm going to just substitute it in. I'm going to take 1.585 and substitute it in for log base 2 of 3. So what I'll end up with then is 4 times 1.585. Okay? So it's just substitution. Instead of log base 2 of 3, I put in 1.585. Instead of log base 2 of 3, I put in 1.585 because log base 2 of 3 equals 1.585. And then I would just say 4 times 1.585 is my answer, which is 6.340. That's 6. Okay. So that's what cut out of my video, and then as we go back into the actual video, I'll be showing you another one of these, okay, and explaining some other things. So this is the one that just suddenly cut out. Okay, it's a substitution. Log base 2 of 3. I could express log base 2 of 81 as log base 2 of 3. So that's what I went ahead and did. All right, and use substitution. So there you go. And then we'll continue on with the original video. Okay, if these two match right here, it equals 1. So for example, so I have, just for example, if I had log base 2 of 2, that equals 1. They match. If I had log base 5 of 5, it equals 1 because they match. So anytime they give you these, you always have another one. Okay, if they're messing with log base 2 of something, you also have log base 2 of 2, and that equals 1, and you can use that one. Okay. The other thing is this. Log to any base of 1, log to any base of 1 equals 0. Okay, so if you had log base 3 of 1, that's going to equal 0. Okay, so you have these two things that you have to use and these. Okay, so you got to use a couple things. Now you're probably wondering why I didn't use this, because the one that I chose just didn't use it. Okay. All right, here's another one for you. Okay, just kind of explain this. So log base 2 of 6. Okay, well log base 2 of 6 could be log base 2 of 2 times 3. And now I'm going to split it up. Log base 2 of 2. It's multiplication. I know if multiplication I'm going to go to addition. Log base 2 of 3. Now, we just talked about this log base 2, if these two match. If these two match, it goes to 1, so that value is 1, and I'm going to substitute 1 in. Log base 2 of 3, we already discussed, and I'm going to use substitution here, and I'm going to put in 1.585 instead. Okay, it's just substitution. Instead of log base 2 of 3, I'm going to use 1.585. And then I just have to add, so my answer then is 2.585. And that's my answer. Okay? The reason that I have to go through this is because I don't know what log base 2 of 6 is. I can't put 6 as a base 2, so I can't solve it unless I know more information, so I have to have more information. Okay? Alright. There's only one more piece to this, so we're almost done, but I'm going to have to switch pages because I ran out of room so quickly. Okay, so this is the last little part, and we're going to solve some equations. All right, laws. Okay, so these would be solved. Now, here's the, I'm just going to have to show you. Log base 5, so this is, we're going to put everything together that we know here. Log base 5 of x equals 3 log base 5 of 2 plus log base 5 of 7. Okay, there's an equation that has an equal sign. And all we have to do is, you know, this is a log base 5. This obviously is going to be some expression of a log base 5. Once we have this as a single logarithm, we're going to be able to just say x then must equal whatever that it's log base 5 of, you know, whatever the of is. All right, so your steps, you know, your first thing you're going to do is write as single logarithm. You can call it a log, but logarithm. Okay, write as a single logarithm. This piece, so I'm going to go ahead and underline it in blue for you so you know that that's the piece I'm talking about. That's what you need to express as a single logarithm. Once we express it, we're going to see that it's going to match, and I'll show you what I'm talking about here. So log base 5 of x equals, okay, I'm using my laws. I'm going to start at law 3 because I'm trying to put it all back together. So I have log base 5 of 2 cubed, right, plus log base 5 of 7. So I have log base 5 of x equals log base 5 of 8, 2 cubed is 8, plus log base 5 of 7. I have addition and multiplication go together, so as I'm creating this one logarithm, I have log base 5 of x equals, I'm going to use multiplication, so log base 5 of 8 times 7, or log base 5 of x equals log base 5 of 56, because that's what they equal. Now, the deal is once your logarithms match, once both sides of the equation, right, are single logarithms, and the bases match, then you can set what's in front of the logarithm equal. Then set then set, I'm just going to say then set equal. So this one and this one I'll show you in color here. So those two are going to be set equal. So what I have then is x must equal 56. And the only way that these can possibly be equal is if this x is 56. Okay? And then that is my answer. And I'm kind of checking to make sure I'm not going to have anything that's not legal here or undefined. And everything would be defined. I have, this value always has to be positive. Okay, it has to be positive. It can't go negative. That means it's undefined. Can't go negative. All right. Now this is a more extreme example. It's more difficult. But hang in there. Okay, this is the last one I'm going to torture you with, and we're going to do a bunch of these in class. So log base 7 of x plus 1 plus log base 7 of x minus 5 equals 1. Okay, now, write as a single logarithm. Okay, well these aren't a single logarithm, so I'm going to write this as a single logarithm. It's addition, so I know I'm going to go to multiplication. So I have log, right, base 7 of x plus 1 times x minus 5. And that equals 1. It's now a single logarithm. My problem, though, is that I said, what did I say? Does that even make sense? 1, both sides of the equal sign are single logs, and I have no idea what I just said there. It's very late right now. It's like 11 o'clock at night. All right. I think I meant to say once. Sorry. I'm going to E there or something. I don't know. I think it says once. That's the only thing that makes sense to me. I told you, though, that, and I'm going to bring back in some old notes here. I told you that right here, that when these match, it equals 1, right? Well, right here I have a 1, but I need the bases to match here on my logs. So I'm going to switch this 1 to a log base 7 so that they match. So what I'll have is log base 7 of x plus 1 times x minus 5 equals log base 7 of 7. This equals 1. I needed these to match. That was the only way I could get them to match. Now what I have is x plus 1 times x minus 5 equals 7. Okay, so once I have these guys matching, these guys then become equal to each other. Okay, so these have to match. Those match. Once those match, I can just say the ones in pink then equal each other. And now it's just a matter of just solving this, and you know how to do that. You're going to have to multiply these together, so I get x squared, minus 4x minus 5 equals 7, and then I'm going to subtract 7 because I need one side to be equal 0. So x squared minus 4x minus 12 equals 0, and I'm going to move this up for you. And then I'm going to refactor this. Remember, we did these already. Looks like 6 and 2. That difference, it's a difference, will give me 4. I know the 6 needs to be negative. That would be positive. And what I'd end up with is x equals 6 or x equals negative 2. Now, my problem is that this number right here, that's right here by the log, it can never be negative. And if I were to put that negative 2 in there, it would end up negative, and that's undefined. If I put the negative 2 in here, it's also undefined. So this one I can't use. The 6, though, is okay, because once I put the 6 in there, I get 7, and that's fine. And I put the 6 in here, I get 1, and that's okay. Now remember, when I told you, if I'm going to get a 7 here, log base 7 of 7 is 1, right? And the other thing that I told you is log base 7 of 1, which is what I would end up here, is 0. 1 plus 0 is 1. And I know now that I have the right answer. So I can check it. I can actually put it back in. What do you think? All right. They take work. They take practice. And we will do that in class. So that is the end of these notes.